Hey guys, it's Mr. Riz here, and we're going to stop, or we're not going to stop, we're going to finish the 2.4 guided notes. So we got day 3. We're going to be looking at what are known as complex conjugates. So complex conjugates are complex numbers with equivalent real parts and opposite imaginary parts, and their product will always become a real number. So we've done examples of this like negative or 7 minus 8i times 7 plus 8i. And what ends up happening is the i's in the middle, the imaginary part, go away. And when we multiply the I squares, it makes it real again. So we end up getting on a real part squared plus the imaginary part squared when it's real, and it becomes nice. So we're going to use that to help us divide by complex numbers. So if I ever want to divide by this complex number here, and there's an example here, but I'll walk you guys through this one as well. I keep typing the wrong one. All right, so if I have 10 divided by 2 minus I, what I want to do here is to realize that I cannot have an imaginary on the bottom. You think of it, if it's like a foundation, you don't want to have anything imaginary on the bottom. It's okay if it's on the top, but nothing below you. You don't want to have a weak foundation. So in order to get this I off the bottom, I'm going to use the conjugate trick. I'm going to multiply the top and bottom both by 2 plus I, the opposite of what is inside of here. So the top here, I can distribute the 10. I'd get, okay, 10 times 2 is 20, and 10 times I is 10I, and that's it. This is real, that's imaginary. We're done with that. And then on the bottom, I'm going to have to FOIL out or double distribute the 2 and the negative I. So 2 times 2 is 4. 2 times I is 2I. And then now multiplying the negative I, we get negative 2 times I would be a negative 2I, and negative I times negative I, or positive I, is a negative I squared. Now we can rewrite this expression some more. Let's see, 20 plus 10, okay, those don't go together, so it's just 20 plus 10I. And now at the bottom here, let's see, those i's would cancel out, and I would get 4 minus I squared is negative 1. And so really this becomes 20 plus 10I over 5. We can take this one step further because I can divide 20 by 5. I can also divide 10 by 5, and I'm going to do that. And so this expression here, 10 divided by 2 minus I, simplifies down to 20 divided by 5 is 4 plus 10 divided by 5 is 2. So it's just 4 plus 2I. So one thing that we have to do when we're dividing by a complex conjugate or a complex number is we're going to multiply by the complex conjugate. There we go. We're going to multiply by the conjugate. We're going to reduce the top, reduce the bottom, and then at the end, double check. This won't always happen, but we're going to see if we can divide both of those numbers by the real number that's on the bottom. Alrighty, so let's move on. Let's try some examples here. Make sure we understand what is going on. Okay, so our goal here. If I wanted to multiply or divide 80 by 2 minus 6I, I'm going to have to multiply the top by 2 plus 6I and multiply the bottom by 2 plus 6I. So this top 80 times 2 is 160. Plus, all right, 80 times 6 is 480I. That's large. Now the bottom here, we're going to FOIL out or distribute the 2. So 2 times 2 is 4, plus 2 times 6I is 12I. Then we need to distribute the negative 6I, so we get a minus 12I, which good because they're going to cancel out. And then we get a negative 6 times a 6I times a positive 6I is a negative 36I squared. Now, if you want, we should probably know right now that this I squared is going to be negative 1. So this is going to make this a plus 36. And then the 12I and the negative 12I, those will cancel out. So really we get 160 plus 480I over, well, 4 plus 36 is 40. Then we're just going to double check, can we divide both of those by 40? Or can we reduce this expression? Can we divide them all by the same number? We can divide everything by 40 here. 160 divided by 40 is 4. 480 divided by 40 is 12. And we have an I there. Okay, it's not too bad. All right, let's do it again now, but let's have this complex number on top of another complex number. So 4 minus 3i divided by -1 plus 2i. I'm going to multiply by -1 minus 2i. So I multiply by the conjugate of the bottom of the denominator. All right, so let's FOIL out the top. 4 times -1 is -4. 4 times -2i is -8i. -3i times -1 is a positive 3i. And -3i times a -2i is a -6, or not -6i squared. It's a positive 6i squared. Maybe I'm thinking a step ahead of what's going to come next. Now on the bottom here, -1 times -1 is a positive 1. -1 times -2i is a positive 2i. 2i times -1 is a -2i. 2i times a -2i is a -4i squared. So let's see, next step. Now the top, the i's don't cancel each other out, but we do have a -4, and we could change this to a -6. So -4 minus 6 would be a -10. And then our i's here, we got -8 and 3, that'd be a -5. So -10 minus 5i on the top. The bottom, the two i's are going to cancel out. And the -4i squared is going to become a +4. So 1 plus 4 is 5. So the last thing we need to do here is see, can we simplify both expressions? Can we divide them both by 5? We sure can. We get -10 divided by 5 is -2. And then -5i divided by 5 is just a -1 or just a -I. So there's that answer. It's kind of crazy how you have these complex problems here and how they simplify to something pretty nice. All right. So eventually what we will do is to realize that we can use these factors later on, especially when we're doing factoring complex numbers here. And if I have like x squared plus y squared, normally we can use the differences of squares, but I can make that now a -I squared. We can use that to help us factor out some other expressions. So I don't believe we are going to do this. So let me just pause right here. I believe I'm skipping this part out of our unit. Let's look at tonight's CYU. Oh, that's why I can't have that. So 2.3. All right. So if you guys notice here, there's several blanks, so that must mean some things don't reduce. So let's go through and do maybe one or two of them together. Okay, so let's start off with a very simple expression here. We got 4i. Now, if I have 4i, I'm going to multiply the top and bottom by its conjugate, -4i. Technically, it's a 0 plus 4i, so let's see what happens. If I multiply by a -4i, I would get 5 times -4 is a -20i. And then 2i times -4i is a -8i squared. All over 4i times -4i is a -16i squared. Okay. So if we wanted to go ahead and rewrite this, let's remember this I squared. Okay, we can't do anything with that. There's no other i's to combine. Becomes -1. So this becomes not a -8i squared, but a +8. And this over here, -16i squared, just becomes a +16. So if I were to write this expression here, I'd have 8 minus 20i over 16. Now we can't divide 8 by 16, we can't divide 20 by 16, but we can reduce all of these by the same number. So what number can I divide all of them by? 8, 20, and 16 by? I can divide them all by 4. And so that's what I'm going to do. 8 divided by 4 is 2. 20 divided by 4 is 5. So we got 2 plus 5i on the top, and 16 divided by 4 is 4. So now if you look, this is the simplified reduced expression, 2 plus 5i all over 4. I'm going to do one more here to help you out. Ooh, save that for some reason. You guys should be okay on that one, Maybe let's do the last. Yeah, do the last one. It's a little weird. All right, so I'm going to multiply by 5 plus I on the top and on the bottom. All right, 13 times 5. Let's see, 13 times 5 is 65. 13 times I is 13i. On the bottom, we got 5 times 5 is 25. Okay. 5 times I is 5i. Now the negative I. Negative I times 5 is negative 5i. Negative I times I is a negative I squared. All right, the top does not simplify at all. It's just 65 plus 13i. And the bottom, let's see, this would become 25. The i's go away. Negative I squared. Let's see, that would simplify down to a plus 1. I squared is a negative 1. Negative 1 is a positive 1. So we have 65 plus 13i all over 26. Can we reduce those? Yeah, we can. We can divide those all by the same number. If I wanted to do that, I can divide them all by 13. 65 divided by 13 is 5. 13 divided by 13 is 1. So we have 5 plus 1i all over 26 divided by 5 is 2. Okay, guys. Hopefully this helped you out. You guys get the hang of this, and we'll see you around next time for the next section.